welcome to the last section of Chapter 3, Section 3.3, Measures of Relative Standing and Box Plots. The first measure of relative standing is a z-score. And we'll be using z-scores a ton, but really they'll come back in Chapter 6. So this is just an intro for right now. So notice a z-score is the number of standard deviations that a given value of x is above or below the mean. So we'll look at an example, but this is how to find a z-score of a sample, and this is how to find the z-score of a population. Notice they're exactly the same, just using the notation for mean and standard deviation, depending on whether it's a sample or a population that you have. Typically, we'll have samples. We want to round z-scores to 2 decimal places. That's just the standard for z-scores. There's a reason for that, and that you'll find out in Chapter 6. So a z-score, as it says, is a standardized value. So what it allows us to do is compare, as you can see in number 3 here, data values from different samples or populations, but you can compare them as long as you know the mean and standard deviation of the sample or population. Typically, we say that if our z-score is between -2 and 2, it's ordinary, it's normal. If it's less than -2 or greater than 2, meaning less than 2 standard deviations away from the mean in this direction, or greater than 2 standard deviations from the mean in this direction, then it's considered unusual, like it's just unlikely to happen. And that's where number 1 comes from. The negative z-score is meaning that it's below the mean. So we'll take a look at an example. We have 2 college roommates. They are both going to take a physics midterm, and they decide that it's a bet. Whoever loses has to do the dishes for a month. Now, Jacob gets an 82 on his physics exam. Michael got a 70. But they didn't have the same instructor, so they're taking different courses. So they both find out the mean for their class as well as the standard deviation. Things to notice are that Jacob's class had a fairly high mean. It was 78, and the standard deviation was 6 points. So these are about points because it's an exam. Whereas in Michael's class, his exam was very difficult. It was with a mean of 55 and a standard deviation of 12. So because of that, it's good to look at the z-score. So I'm going to say z-score for Jacob. Remember from the last slide, which you have at the top of your page, that to find the z-score, you take the data value, which is 82 for Jacob. You subtract the mean, and you divide by the standard deviation. And that's going to give you 4 divided by 6, which is about 0.67 to 2 decimal places. So that means that relative to the other students in the class, he was a little bit above the mean, not quite 1 standard deviation above the mean, but between 0 and 1 standard deviations above the mean. For Michael, his score was a 70, but the mean was a 55 and a standard deviation of 12. And if you do this math, you'll find that Michael got a 1.25. His z-score is a 1.25. So what that means is that Michael actually did above 1 standard deviation away from the mean. So remember, at least in a normal distribution, the majority of the data values gather around the mean. And so the further you go out from the mean, the more unusual your data value is. So what this tells us is that relative to his class, Michael has the better score. And that's why z-scores can be very important, because they allow us to compare. Our second measure of relative standing is percentiles. Percentiles help us to locate a value in relationship to all the other data values in a data set. There's some notation. We have L, that tells us where to look in the data set, and we have P, which is P sub K, which is telling us what percentile we're in, and K will be a number. some number. So in order to find a percentile, we do this. And we'll look at an example. One kind of real world example of percentiles is when you have a child and that child has to go to the doctor periodically to get checked up. And what they normally do is take measurements, and they take measurements to find out what percentile the baby sits in. And that kind of allows parents to know if their baby is a good weight, a good height, in case there's things that they need to change. So this is an example of a baby with a very, very big head. And maybe you know a baby with a very, very big head. But this baby's head is bigger than the rest of its body, as you can tell. It's not really proportional, but that is one thing they check when they go to the doctor. They actually measure the circumference of the head. And this baby, for example, might be in like the 90th percentile, or P sub 90 for head size. Like, it's possible that whatever that head size is, I think they say circumference, head circumference, that's where that baby's head circumference sits in relationship to all the other babies that are born in this world, that baby's head is quite large. And so if your baby's head is in the 50th percentile, it's absolutely average. It is right in the middle, and half the babies have a larger head and half the babies have a smaller head, but your baby's right there with a lot of other babies. It's when babies have that really high 90th percentile, or maybe like a 5th percentile, that parents might get worried, especially if that was something like weight. You don't want, a baby that doesn't weigh enough, because maybe that means it's not getting enough food or something. So percentiles are used a lot in the medical field in that way. The other thing you can do is, if you are given a percentile, you can find the value that's in the percentile. So there's two different things that we do. So I'll refer back to these as we do our examples. So we have a data set, and it represents 38 randomly selected homes. And these prices are in thousands, so understand that. And our job is going to be to find a percentile and then find a home price that relates to a certain percentile. Notice that the values are already in order. So that's super helpful to us, because if you do want to answer questions like this, your value does need to be in ascending order. So ascending order, or else you're not going to have the right answer. So the first question says, find the percentile corresponding to a selling price of 188,000. So the first thing you'd want to do is locate 188 within the data set. So find that. Okay. Now, if we follow the directions from the part where it says find a percentile, so if you go back to the first page of this, your notes, you'll see that the percentile relates to the way that you find that, because you're finding some P here. It is the number of scores less than the given score. So we take 188, the number that is less than that. So count how many of the values are less than 188. So hopefully you counted 23. And then there are 38 total values, and that's the bottom, total number of scores. So notice this is a fraction. And so what we would need is, we're trying to come up with a percent, so we need to change this. So put this into your calculator, and what you should find is that you get 0.60526, something like that. And then typically we would then round that. So know that that's about 0.61, which then changing that into a percent would be 61%. So that's going to be the 61st percentile. So that means that 61% of the values sit below 188,000, and then the other 39% of the values sit above. That's the idea. In order to find the home price corresponding to the 85th percentile, what we would do in a situation like that is we would follow the directions that you'll see from the top of the page here, which says that the first thing you need to do is find the locator value. So it's basically telling you where to go inside your data set to find the value that you need. So you take, as you can see in the formula, the K is your percentile, so that's 85, divide it by 100, and then multiply by the number of values. That's what the N means, number of values. So we multiply by 38, and we see what we get, and we are going to get 32.3. And so what you'll see in the notes for this finding the score associated with a given percentile is if L is a decimal, as this is, we always round up to find the score we need. So this is not a home price. This is where to look in the data set. So we need the 33rd value. So looking at finding the 33rd value, this is in order. So this would be the 38th, 37, 36, 34, 35, 33. So that tells us that the value in the 85th percentile is 233,000.